Welcome back, guys. And in today's one we take a look at the fascinating science behind Atlas from Boston Dynamics. Atlas is the most dynamic humanoid robot currently on the market. Its state-of-the-art hardware gives the robot the power and balance to demonstrate human-level agility. The robot has one of the world's most compact mobile hydraulic systems. The custom battery, valves, and a compact hydraulic power unit enable Atlas to deliver high power to any of its 28 hydraulic joints for impressive feats of mobility. Atlas's advanced control system enables highly diverse and agile locomotion, while algorithms reason through complex dynamic interactions involving the whole body and environment to plan movements. The robot uses 3D printed parts to give it the strength-to-weight ratio necessary for leaps and somersaults. By training Atlas to maneuver its way through complex parkour courses, Boston Dynamics engineers develop new movements inspired by human behaviors and push the humanoid robot to its limits. Let's take a look at how Boston Dynamics are building a foundation with Atlas. A robot's ability to complete a backflip may never prove useful in a commercial setting. But it doesn't take a great deal of imagination or sector-specific knowledge to see why it would be helpful for Atlas to be able to perform the same range of movements. If robots can eventually respond to their environments with the same level of dexterity as the average adult human, the range of potential applications will be practically limitless. Humanoids are interesting from a couple perspectives, Koindersma says. First, they capture our vision of a go-anywhere, do-anything robot of the future. They may not be the best design for any particular task, but if you wanted to build one platform that could perform a wide variety of physical tasks, we already know that a human form factor is capable of doing that. From a technical perspective, humanoids present several challenges that we welcome as a research team, he adds. Their combination of size and complexity creates hardware design trade-offs related to strength-to-weight ratio, runtime, range of motion, and physical robustness. At the same time, our control team has to create algorithms that can reason about the physical complexity of these machines to create a broad set of high energy and coordinated behavior. Ultimately, pushing the limits on a humanoid robot like Atlas drives hardware and software innovation that translates to all of our robots at Boston Dynamics. Parkour, as narrow and specific as it may seem, gives the Atlas team a perfect sandbox to experiment with new behaviors. It's a whole body activity that requires Atlas to maintain its balance in different situations. It's really about creating behaviors at the limits of the robot's capabilities and getting them all to work together in a flexible control system, Koindersma says. There are many important problems that parkour doesn't force you to address, but that's not the point. We're not trying to solve everything all at once. The work we're doing now is allowing us to create a solid foundation. Looking back over 5 years of Atlas videos, it's easy to lose sight of just how much progress the team has made during that time. In fact, some of the improvements are invisible to the average viewer, even though they represent giant leaps in technology. Atlas's moves are driven by perception now, and they weren't back then, Koindersma explains. For example, the previous floor routine and dance videos were about capturing our ability to create a variety of dynamic moves and chain them together into a routine that we could run over and over again. In that case, the robot's control system still has to make lots of critical adjustments on the fly to maintain balance and posture goals. In this iteration of parkour, the robot is adapting behaviors in its repertoire based on what it sees. This means the engineers don't need to pre-program jumping motions for all possible platforms and gaps the robot might encounter. Instead, the team creates a smaller number of template behaviors that can be matched to the environment and executed online. Simulation is an essential development tool for the Atlas controls team, both for evaluating new behaviors prior to robot testing and for ensuring that new software changes don't negatively impact existing capabilities. But there's still no replacement for hardware testing, particularly in performance-limiting motions like vaulting. About that vault. Unlike high-flipping gymnastics vaults, a parkour vault is a slightly less flashy method, designed to get a runner over a low wall or obstacle. In this case, the balance beam, only a few feet high. Atlas places its arm on the beam and then hoists its body over the structure. For many humans, this sort of vault would be relatively easy. But for the Atlas team, it represented a formidable new challenge. If you or I were to vault over a barrier, we would take advantage of certain properties of our bodies that would not translate to the robot, Puindrisma notes. For example, the robot has no spine or shoulder blades, so it doesn't have the same range of motion that you or I do. So guys, I hope that demonstrations like this provide a small glimpse of what's possible. So where do you see the future of Atlas? A robot for show or a marketable product adopted by humanity? Please leave your opinions in the comments and have a good day. So guys, I hope that demonstrations like this provide a small glimpse of what's possible. So where do you see the future of Atlas? A robot for show or a marketable product adopted by humanity? Please leave your opinions in the comments and have a good day.